Stephen Hawking's name is synonymous with the mysteries of the cosmos. Born in 1942, his life's work transformed our understanding of black holes, the nature of time, and the very fabric of the universe itself. But perhaps one of the most mind-bending ideas he engaged with was the concept of parallel realities, a multiverse, where infinite versions of existence play out across a vast cosmic stage. Could Hawking's towering intellect have glimpsed these other worlds, and what did his theories truly say about the possibility of parallel universes? To answer this, we must first journey into the heart of Hawking's thinking, the relentless drive to understand not just what the universe is, but why it is the way it is. Hawking famously said, "My goal is simple. It is a complete understanding of the universe, why it is as it is, and why it exists at all." This quest led him to some of the most fundamental questions of existence. Why does the universe have the laws it does? Why does it exist in a form hospitable to life? And, most provocatively, are there other universes, governed by different laws, where reality itself could be unimaginably different? The idea of parallel universes, or the multiverse, is not new. Ancient philosophers mused about infinite worlds, and science fiction has long played with the notion of alternate realities. But for much of scientific history, these ideas remained on the fringe, dismissed as speculation rather than science. That started to change in the late 20th century, as advances in quantum mechanics and cosmology opened new doors to understanding the deep structure of reality. Stephen Hawking's work sits at the intersection of these new ideas. His early contributions focused on black holes and the birth of the universe, singularities, points where the rules of physics seem to break down. In the 1970s, Hawking's groundbreaking calculations showed that black holes are not eternal prisons from which nothing can escape. Instead, thanks to quantum effects, they emit radiation, now known as Hawking radiation, and can eventually evaporate. This discovery was revolutionary, bridging the gap between Einstein's theory of general relativity and the strange world of quantum mechanics. But Hawking's intellectual curiosity did not stop at black holes. He wanted to understand the origin of the universe itself. In collaboration with James Hartle, he developed what's known as the no-boundary proposal, a radical idea about the universe's beginning. According to this model, the universe didn't emerge from a singular point in time, a dramatic bang, but rather from a smooth, rounded geometry, like the North Pole of the Earth, with no sharp boundaries. In this framework, time itself is a property that emerges as the universe cools and expands. This theory was an important step towards reconciling quantum mechanics and cosmology. But what does all this have to do with parallel realities? To answer that, we need to dive into the concept of the multiverse. In physics, the multiverse refers to the idea that our universe, everything we can observe and measure, might be just one of many, perhaps an infinite number, each with its own laws, constants, and histories. There are several flavors of the multiverse hypothesis, and Hawking's work touched on some of the most compelling. First, there's the many worlds interpretation of quantum mechanics. According to this view, every quantum event, every moment when a particle can go one way or another, splits reality into parallel branches. In one branch, the particle goes left, in another, it goes right. The result is a vast, branching tree of realities, each as real as our own. While Hawking acknowledged the philosophical intrigue of this interpretation, his primary focus was on cosmological multiverses rooted in the physics of the early universe. Next, consider cosmic inflation, a theory developed in the 1980s to explain why the universe appears so uniform and flat, no matter where we look. Inflation proposes that, in the first fraction of a second after the Big Bang, the universe underwent a mind-bogglingly rapid expansion, stretching tiny quantum fluctuations into vast structures that would later become galaxies and clusters. But inflation doesn't necessarily end everywhere at once. In some models, it keeps going in different regions, creating bubbles or pocket universes, each with its own properties. This is called eternal inflation, and it leads naturally to a multiverse, a vast cosmic foam of universes, each perhaps with different laws of physics. Hawking was fascinated by these ideas. In fact, some of his later work with physicist Thomas Hertog tackled the question of how many universes might exist and whether we could ever meaningfully talk about them. In their 2018 paper, one of Hawking's last, they proposed a new way of thinking about the multiverse. Instead of an infinite cosmos with infinite variations, they suggested that the multiverse might be more limited, more finite, and potentially testable. But did Hawking's intellect allow him to foresee parallel realities? In a sense, yes, but not in the way of a mystic gazing into alternate worlds. Hawking's genius lay in his ability to take the wildest ideas of modern physics and tame them with mathematics, to follow the logic of theory to its ultimate, sometimes unsettling conclusions. He didn't claim to see other universes. Instead, he asked, given what we know about quantum mechanics, gravity, and the birth of the cosmos, what does the math suggest? Are there scenarios in which parallel universes are not just possible, but unavoidable? For Hawking, the answer was often yes. His work showed that, under certain assumptions, the laws of physics almost demand the existence of other universes. In fact, the very fact that our universe seems so fine-tuned for life, so perfectly balanced in its physical laws, may point to a multiverse. If there are countless universes, each with different properties, it's not surprising that we find ourselves in one where the conditions are just right for observers like us. This is known as the anthropic principle. It's a controversial idea, but it's one that Hawking was willing to consider. As he put it, the universe doesn't allow for just any old set of laws. It has to have laws compatible with the existence of life. In a multiverse, this becomes less mysterious. There are many universes, but only in some do the laws allow for life, and only in those can beings like us ask these questions. But Hawking was also cautious. He knew that science is not just about what's possible, but what's testable. He often emphasized the importance of observable predictions. If a theory predicts the existence of other universes, but we can never observe them, is it really science? Hawking's later work tried to address this by suggesting ways that the multiverse might leave subtle fingerprints on our own universe, patterns in the cosmic microwave background, for example, or traces in the distribution of galaxies. If we can find such evidence, the multiverse moves from speculation to science. So could Stephen Hawking's superintelligence have helped him foresee parallel realities? In a way, his intellect allowed him to take the most perplexing questions of modern physics and pursue them to their logical extremes. He didn't claim to have direct knowledge of other universes, but he showed that the mathematics and theories we use to describe our own universe often point toward the existence of many. Hawking's approach to the multiverse was always grounded in rigorous reasoning. He was not content to accept wild speculation without evidence. Instead, he sought to find testable consequences. For example, he and Hertog's later work suggested that, if the no-boundary proposal is correct, then the cosmic microwave background, the faint afterglow of the Big Bang, should have a certain pattern, one that might be observable with future technology. In this way, Hawking tried to bring the multiverse within the realm of empirical science. It's important to recognize that the multiverse is not a single unified theory, but rather a family of related ideas. Some versions, like the many worlds interpretation of quantum mechanics, are almost metaphysical, making claims about the fundamental nature of reality. Others, like eternal inflation, arise from models of the early universe, suggesting that the physics that gave rise to our cosmos may have played out differently elsewhere. Still others come from string theory, which suggests a vast landscape of possible universes, each with different physical constants. Throughout his career, Hawking engaged with these ideas, always seeking clarity and coherence. He was unafraid to challenge orthodoxy, but also careful to avoid untethered speculation. He understood that science advances not just through bold ideas, but through ideas that can be tested and refined. So, where does this leave us? Are parallel realities more than just science fiction? Thanks to Stephen Hawking's work, the possibility is now taken seriously by many of the world's leading physicists. The idea that our universe could be just one bubble in a vast cosmic foam is no longer dismissed as fantasy, but considered as a real, if still speculative, extension of our best theories. But what would it mean if parallel realities do exist? The implications are staggering. Somewhere, perhaps, there is a universe where the laws of physics are slightly different, where stars never formed, or where life took an entirely different path. Somewhere else, perhaps, there's a version of you, living a life with different choices, different outcomes. The multiverse stretches the imagination and challenges our deepest assumptions about reality. Yet, as Hawking would remind us, we must remain grounded. The task of science is to seek evidence, to test ideas against observation. The multiverse remains, for now, a tantalizing possibility, one that may help explain some of the deepest mysteries of existence, but which still awaits its crucial test. Hawking's legacy is not just in the specific theories he developed, but in the spirit with which he approached the unknown. He was willing to follow the logic of science wherever it led, even to the bewildering possibility of infinite worlds. But he was also humble before the vastness of the cosmos, knowing that our quest for knowledge is always incomplete. In his final years, Hawking remained optimistic about the power of human reason to uncover the secrets of the universe. He believed that, with enough creativity and perseverance, we might one day answer the great questions. Why does the universe exist? Why does it have the laws it does? Are we alone, or do infinite realities unfold beyond our own? In the end, the question of parallel realities may remain unanswered for now. But thanks to Stephen Hawking and his fearless intellect, we have the tools and the courage to keep asking. As we gaze into the night sky, pondering the mysteries of existence, we are following in Hawking's footsteps. We are seeking not just to understand our universe, but to imagine what else might be possible. In doing so, we honor the legacy of a mind that refused to accept the limits of what is known, a mind forever reaching beyond the horizon into the infinite possibilities of reality.